Good day again. Welcome back. So today we're going to look at this question. It's actually a topic in analytic geometry. So the concept is distance between points and lines. And this specific topic will cover about 3 topics, give and take. These are 3 main topics. So one is graphing analysis. We have to graph a certain function. And then we need to solve a system of equations because that's how we have to be able to connect and relate to the two information that we have. And then the last piece is that we're going to use distance formula or Pythagorean theorem to come up with the distance value, which that would be a distance calculations. So the question is, find the shortest distance from the origin to the line y equals to 3 over 2x minus 10. So the first thing we have to do, we have to graph this, okay? So let's look at how we're going to graph that. So the first thing we have to do, graph this. Now, I will use the Desmos to graph this, but you should not have any issues to graph this freestyle using the y-intercept minus 10 and the slope. All you need is 2 points, and then you can draw a straight line through. And we know the origin in the Cartesian coordinate, the coordinate of origin is 0, 0. All right, so let's look at the graph now. So here is the graph. I graphed it, and the red line is this equation, y equal to 3/2 x minus 10, and then the origin 0, 0, which is labeled right there. Now the question is, what is the shortest distance between this point and this line? And in geometry, the shortest distance between any two, either lines or a point on a line, is straight and perpendicular to the line. So that means intersect at 90 degrees to the line y equal to 3/2 x minus 10. So this is what we have to deal with. All right. First, we need to find the equation of BA. That's the first thing we need to do, because once we know the equation of BA, then we can find the point of intersection which be of BA and the line y equal to 3/2 x minus 10, and that coordinate xy for point A, that point of intersection will be used to find the distance between A and B. All right, to do this though, we have a couple of information that we can use. First, we know that here it is, I've made a circle or an arrow on this, but we know the slope of the original line. Okay, and because it says the shortest distance, as I explained just a few seconds ago, the shortest distance between a point and a line is a perpendicular line from that point to the line. Now, if it's perpendicular, so you can now call AB, the line segment AB, perpendicular to the line y equal to 3/2 x minus 10. And as a refresher, let me remind you that whenever you have two lines perpendicular to each other, that's just notation for perpendicular right there, then you have a relation in their with their slopes, that the first slope or slope of one line is negative reciprocal of the second slope. Or in some text, they write it as when you multiply the two slopes, you get -1. Same idea. Now that we know the slope of the first line, so the red line, the original function that is given to us is 3/2, and you can just read it off of the equation. This is the linear equation in a form of, by the way, remember the form of a line, y equal to mx plus b. That's the linear function, where b is the y-intercept and m is the slope, right? So if this is the slope, that's what we can extrapolate that value right from the equation. All right, if that's the case, then the slope of the new will be the negative reciprocal. Reciprocal means you flip the fraction, okay, and put a negative in front. So now we know the slope of the line segment AB, do that too. So the slope of AB like that. In some books they write it like that as well. Okay, so you can actually use that. And now that we have that point, let's go ahead and find the equation of the line segment AB, or at least the equation of the line that part of that line is a line segment of AB. Now that you have the equation, or sorry, the slope of the line segment AB and a point, remember 0, 0, the origin is part of the line segment AB, right? So now we can find a line that goes through the entire thing, and the line segment of that line is AB. So we can now go ahead and find that equation. And remember the equation y equal to mx plus b, and where b in this case, remember, is basically y-intercept, right? So that's your y-intercept, and y-intercept in this case, if you look at it, well, it's 0, 0, right? 0 is for x, 0 is for y. So y-intercept is actually 0. So we know b is 0. Great. Now that we know b is 0, we also have m. We're just going to substitute that into the equation. So the equation would be y equal to negative 2/3 x plus 0, but I'm not going to write the 0, and that would be the equation of a line that AB is a line segment of that line, and it goes through 2 points AB. Now, the next step, last step, is we need to find the point of intersection of the line y equal to negative 2/3 x, which is the line segment BA is on it, and the original graph, the line y equal to 3/2 x minus 10. Now, to do that, we're going to use system of equations. And to do that, there are two ways to solve that for that point of intersection. One is either graphic method or algebraic method. I'm going to start with setting up the algebraic method, but I will not solve it algebraically. I'm going to go use the graphic method. All right, so let's go ahead and do that. Here is the system of two equations and two unknowns. Both lines are here. You're going to use substitution method. And what I will do, I will not going to go and solve this system algebraically, but I will link a video to review how to solve system of equations using substitution. And you can click on that, review that, and come back. It's not very hard. Just substitute it for y and go ahead and solve. All right. But for the purpose of this example, I'm going to show you graphic method. All right, let's go to the graph. I have the original graph here. I'm just going to type in negative 2/3 x, and here it is. Okay, so that is the green graph where the line segment AB starting from 0, 0, and this point right there, that's the point of intersection. And the graph Desmos is actually giving me this value, which that's what I want. And we're going to round it up to, just for simplicity's sake, to 1 decimal place. So 4.6 and then negative 3.1. Those are the two values, the x value and a y value, the coordinate for the point of intersection of the two lines. All right, now that we have the point here, the point of intersection and the origin, and we know that this line is perpendicular, that means they intersect at 90 degrees. Now we're going to use distance formula or Pythagorean theorem. Basically, that's what that is. Distance formula is Pythagorean theorem to come up with the distance between the origin and the point of intersection of the two lines. Okay, let's do that. Have the points written, and also I have labeled each of the points. So what I have done, by convention, I used the origin. I labeled origin coordinates x1, y1, and the point of intersection x2, y2. But it doesn't need to be like that. You can actually switch them. You can change the point of intersection to the first point and then the origin, the second point. It doesn't really matter. And then here is the distance formula we have, which is Pythagorean. And now we're just going to substitute values in for x2, x1, y2, y1, and then solve and find out what the distance is for the line segment AB. All right, and here it is. I just substituted values for x2 and x1 and y2, y1 based on the coordinates I have, and go through it and make sure that you're plugging in values properly and you're not mixing them up. This is the most commonly mistaken step by students. So make sure you stick with the x2. That what is x2 is 4.6. What is x1 is 0. Don't mix and match them. They have to follow the same order. And then when you plug numbers in and you simplify, you will end up getting 30.77 under the radical sign. Remember, the negative 3.1 squared, the value will that be positive. And then when you take the square root of that, you're going to get approximately 5.54707 and more. But I just wrote it down as 5 decimal expansion. And then at the end, if you want to make it to 2 decimal expansion for answer, it would be 5.55 unit, whatever the unit is. So here is the final answer. We answered the question, what is the shortest distance between the point, the origin, and the line y equal to 3/2 x minus 10. The shortest distance is 5.5 units. But notice that there were at least three separate mathematical concepts that we used. I hope this was useful. Until next time, take care.